Hi, my name's Martin Smith, and I'm going over a physics problem given by the Higgins optics channel. The experiment that I'm looking at is the real double slit experiment. It's one of the things that has always fascinated me. Subconsciously, I've always believed that the field effect that caused the interference was in the double slits. And early last year I did an experiment with lasers, and I used paper because it wasn't metal, thinking that it's a magnetic effect inside the electrons of the material that the slits are made from, or the material stopping it. And it turned out that paper gave the same results as if I used a foil slits with a basic laser. But still subconsciously, I believed that it came from the interference of the foil or the material that was at this point of the slits. And this Higgins optics channel went over one where he used a microscope. So he's taking the light that comes from the slits, putting it through a lens, and then putting it to a camera backing. So this gives a complete different operation of getting the same results. And in fact, he not only got different results, but by changing the focal length, he could look at different aspects of the wave pattern. So I looked at this, and immediately my subconscious, or if you prefer gut feeling, said, hey, this isn't happening the way I thought it was. The interference is actually coming from either the camera or it's coming from the wall in which this thing was projecting onto. One of the aspects of why it dawned on me that the interference was actually coming from the wall, and that there was magnetic resonance within the wall itself, is that another experiment I did years ago where I shined a laser on one wall, let it reflect onto the other, and I started looking at all the dots. And as I moved the laser, those dots, they stayed in the same pattern. So that tell me there's more to what I'm really looking at with this double slit theory or slit experiment. And it's something similar to the Bernoulli experiment, where you're looking at the Bernoulli effect, and we don't explain it through the actual motions of the atoms that the Bernoulli effect is going through. We're explaining it through mathematics. And similar to the problem of the subconscious saying, oh, gut feeling, this is how it works, not really working it through, and then it's real easy just to get on a high horse and say, yes, it is working this way. A lot of people will consider proof because they spent their life savings, their parents' life savings, and are in so much debt it'll take them the rest of their lives to get out of it, just to get a college degree to learn material that's not exactly true. So anybody coming up with proof that it's not true, how dare they? The subconscious likes to work that way too, and you have to be real careful of it. Yes, I have a gut experience. Okay, so now I have a new gut feeling that this is the way things work. My subconscious is telling me that this is the way things work. It comes up, and the interference is coming from the wall itself or from the computer chip that is gathering the light and making an image from the light. So I put my new eureka moment on the written part on the comment section, and someone spoke up and said, that's not the way it works. It comes from the slits. And all of a sudden, I don't really have any proof of it. So what I did is I've done a long And I did a whole bunch of drawings, and these are optic drawings, what you see for just basic optics. And it's about drawing straight lines, saying that photons follow straight lines. Well, everybody knows photons follow waves, and they follow wave patterns, and straight lines don't do anything. But I'm going to use, okay, fine, I have a bad sense of humor. I'm going to use straight lines to represent the path of photons, individual photons. And let's go ahead and get into it. Okay, the first issue that I need to look at is Higgins optics channel was using microscopes, so I went and I got some of my microscope lenses. This one is a non-oil lens. It's a 97 power. This one is a 40 power. However, it has one difference in that, as you can see, it moves inwards, and that means it's meant to work with oil, so that you can put this thing right up against the glass plate, put some oil in between, and it'll actually press in to allow you to get different focal lengths within that oil. But what they do is, as you can see, that thing is really, really small compared to that one. So the size of your optics matters when you're drawing out optics. And when I do this and I put it up here, I'm getting about 58, and that's 25.4 thousandths of an inch to a millimeter. So I'm actually I was really getting around 60 to 62 thousandths. So anyhow, that's still around 2 millimeters. So I can throw all this stuff aside and I can say the slit distance cannot be anything more than 2 millimeters, or can it? So I'm using basic tools to do this rather than using a computer to define all these things. Move that up a little bit. So the experiment is using optics to get a focal point, and that focal plane is what we're really looking at in theory. So as he moves this thing back, he starts out with double slits. Actually starts out looking at something weird, and I'm not sure how he got it, but eventually we got the double slits as in we saw them. And that tells me that the light, even though the light goes in a straight line, the direction of it pretty much works as a wavelength, or as a waveguide rather than straight lines. So how is it hitting it? How is it hitting the lens, and where is it going from there? Because what we need is wherever it is interfering, that is where we're going to see these double lines. So what this said is that there is a point in which the interference isn't coming from here, but it is actually coming further back. So going to it, I'm looking at focal lengths, or focal points, compared to the slit plane. That's the slit plane. This was my initial belief of where the resonance was coming, as in a photon would come through here. A photon has a positive charge on one side and a negative charge on another. If you look at the classical way of looking at physics, you'll see that straight line with the magnetic waves going this way and the charge going the other. I can't. It's early in the morning. My mind's not functioning too good. Anyhow, no matter which form you look at it, a photon has a negative and positive charge, and my belief was that negative and positive charge was influencing the electrons in these three plates, in that it was creating a magnetic resonance, and that resonance, as the charge came this way and became negative charged, and the photon came through here as a negative, it would push it that direction. If it came through as a positive, it would push it that way. If it came through with a negative and positive charge going up and down, it'd go straight through. And it made sense, it looked right, and all of a sudden it doesn't. So why is it not looking right? So how this works is you take a focal point on this, and I'm taking an arbitrary lens, arbitrary focal length, and I'm making it go from the lens to, and that's the center of the lens, to your slit plane. And how this works is you take a protractor, and this is a machine shop protractor, and you follow this line going across here, your straight line to the image detector, whether it be your eye or anything else, and you put this one down the focal plane and you lock it in place. Now any light hitting this thing, this point here, is going to have the same bend, so I can take it up to the top slit and go from here, and what's happening is this dotted line is actually not hitting, no light from this slit is hitting the imagery. So I know that the slits have to be much smaller than the distance of the lens. So I had a lens of 2 millimeters, so I know my slits can't be anything more than 2 millimeters to work with this experiment. My second one is I did one with the slits being the same distance as the diameter of the lens, and my third one I did the slits being bigger, and all three of these fail, as in no light actually gets to the receiver. So my last one, which actually works out, if I have the focal point on the slit plane, then what I'm getting is, and I'm doing a I'm doing a double slit on this one, but it is a real small slit compared to the size of the lens. So on this one, we're getting light from here. I'm going to go to this side first. I'm getting light from here. Oh, excuse me. This one goes here to the top, which means, and I'm also getting light from here to here. So on this one, I'm getting light from here to here. On my top one, I'm getting light from here to here. And only from here to here is this light crossing over. Now this is where the problem comes in, because each one of these slits has interference within itself. That means the light's hitting the side, and the side of the slit plane as it's going through. So when I have a photon going through, it is electromagnetic. The slit plane is electromagnetic, and it is interfering, and some of the photons are actually being bent, and they're going in all different directions. Now most of them are going straight forward, and there is a curve to it. So right here we're seeing the curve. Most of the photons are hitting here and here, but yet the photons that are hitting the side on this one are actually interfering with the majority of photons coming through the other slit. And what that's doing is I'm getting interference back here. So the question now is, if it's not being interfered with through the slit plane, is the interference coming from the lens or from the backing itself? Now, subconsciously, gut feeling, so to say, I'm just going all in and saying it's coming from the backing. How do I prove it? So, went back and watched the video about 20 times. And, some of the points that I thought were being stated in two different places, and it makes a difference. So the first image we got was an image of a whole bunch of little dots with a round circle, and not exactly sure where that came from, but in theory the focal point was behind the slit plane, the focal point being behind the slit plane. So we have light coming through here, and this is the image that it makes, though I'm not really 100% sure on how that was done. I didn't see how the microscope was being brought upwards from the slit plane. Focal point is less than the slit plane. What I'm getting is we get an image. We're getting two things through here. One, we're getting an image of the slit, and also on this one I'm using a single slit. So we have an image of the single slit, and we're getting the single slit. Where's my ink pen? So we're getting this right here. We're getting a big spike. We have lots and lots of photons hitting here. But what we're also getting is we're getting pass-through. That means the light hitting the sides is going in all directions. Most of the photons are going straight, but some of them are going off, and some of them are coming out here. So outside of this, we have light that is coming off of here and here. So we have actually this works similar to a double slit. So we actually do get little fringe marks out here from the double slit, and that was shown on one of his videos. I'm not sure if it was the one that I listed. So if I look at a single slit again, again it shows me the same wave fronts, and what it's telling me is that it could either be coming from the lens or from the backing, and I just plain outright haven't figured that one out yet. But this is this video is about explaining a possibility. It's explaining where I feel that I went wrong, and I understand that I'm not going to prove everything to everybody, and here it is, so to speak. So do with this as you will, and I will see you on another video.